Example 3 is looking at more of a real world type problem. So here we're dealing with hot air balloons. A hot air balloon's height varies directly as the balloon's ascent time in minutes. So right here it's telling us that it's going to be direct variation. It takes the balloon approximately 5 minutes to ascend 350 feet. About how many minutes would it take to ascend 2,100 feet? And about how many minutes would it take to ascend 3,500 feet? So in this, it's a little bit more difficult because we're not told what X and Y are. We actually need to kind of figure that out. So whenever you deal with these types of problems, notice how I identified varies directly. I identified those words in that sentence. So when we look at that initial sentence, whatever comes before varies directly, in this case height, it's always going to be our Y. And whatever comes after varies directly, which is our time, our ascent time, that's going to be our X. So an easy way to remember that, the equation for direct variation is y equals kx. The y comes before the equal sign, the x comes after. So when we look at our information now, we can see that it takes approximately 5 minutes to ascend 350 feet. So that's basically going to be our first x and y value. Remember that height is our y and time is our x. So when I set up my equation, I have 350 equals k times 5. Just going to solve for k here, dividing by 5 on both sides. And we'll get k equals 70. Now what's important, especially as you get into these more real world type problems, is that you actually understand what that k is. So if it takes 350 feet, takes 5 minutes to ascend to that height, that 70 is basically just our speed. It's the rate at which we are increasing. So if I were to take the height divided by the time, that's going to give me my rate. So basically what this is saying is that our hot air balloon is ascending at 70 feet per minute. Now we can use that because if we understand that, we can then approach this problem in different types of ways instead of through just a direct variation type of problem. So it's important to identify that, but let's go ahead and let's continue through with our direct variation equation, since that is our focus of our lesson today. So in this, instead of writing y equals kx, remember that we now know that k is 70. So I'm now going to use the equation y equals 70x. And if I look further, I'm asked about how many minutes it would take to ascend 2,100 feet. So we're going to input 2,100 for y, since we identified that as our y value. And we're going to solve for x. We should come up with 30. So remember, x was our time, so 30 minutes is how long it would take to ascend to 2,100 feet. Now, I do want to remind you that this varies directly, which means that the rate is going to stay the same. So the balloon's not going to go up and down at different speeds. It's not going to go faster and then slow down. It's going to be going at a constant rate that whole time. Now, this problem also asks for an additional situation where it wants to know how long it's going to take to go 3,500 feet. So we'll again come back to that new equation that we developed when we found k, y equals 70x. We'll input 3,500 for y. And we'll solve for x again in this situation. And we should come up with 50. So it's going to take 30 minutes to ascend 2,100 feet and 50 minutes to ascend 3,500 feet.